last time when we met, I told you that our channel was near to 200 subs, but now it is more than that. I guess our next target is reaching 250 subs really very soon. Till now we have gone through the moment of force, that is turning effect due to the force acting on an object. We have also gone through couple and the moment of couple, how does it work, how to derive the formula. Now today we are going to talk about the equilibrium of bodies. In simple terms, we have understood till now that suppose if an object is at rest and if it does not change its state of motion, then that object is said to be in equilibrium. Now what if the object is performing linear motion or rotational motion, then can still you call it in equilibrium, and how does it work? Now going into a little deep, suppose if there is an object which is at rest. As we know, there are more than two forces acting on an object, but still it remains at rest. That means the state of rest does not change. Instead of application of many forces, number of forces, in that state is known as static equilibrium. Equilibrium has two types. The first one is static equilibrium and the second one is dynamic equilibrium. So if the object is at rest and the number of forces are applied on the object but still it remains at rest, then that is known as static equilibrium. That means the summation of all the forces, the net force acting on the object is equal to 0. The resultant force is 0. Now what if an object is performing a linear motion or rotational motion and still on application of a number of forces it still remains in linear motion or rotational motion uniformly? That means the motion does not change, it remains as it is. And that kind of an equilibrium of an object is known as dynamic equilibrium. That means suppose if an object which is pivoted at the center is acted upon by many forces, then the anti-clockwise moments produced by the forces and the clockwise moment produced by the forces will cancel out each other in such a way that the object remains stationary. Or in case of dynamic equilibrium, the object continues its motion uniformly. So there are basically two conditions required for obtaining equilibrium. The first one is the resultant of all the forces must be equal to 0. That means all the forces cancel out each other, equal and opposite forces. Thus the resultant of all the forces is equal to 0. And the second is the algebraic sum of all the moment of forces that is acting on the object about the fixed point is equal to 0. That means suppose if we consider this rod which is hanged with a rigid support at the point O, and let us say a few of the forces are acting at the side B and a few forces are acting on the side A, but the moment produced by the forces acting on the side B about the fixed point O and the moment produced on the side A about the fixed point O will cancel out each other and the rod will still remain horizontal. Then it is said to be in equilibrium. From this we come to a new concept that is known as principle of moments. Now what is it? To sum it up in one line, it is sum of anti-clockwise moments equals to the sum of clockwise moments. Now what if we want to prove this principle of moments experimentally? We have to verify it somehow. So let us perform a small experiment. Let there be a uniform meter rule which is tied at the point O, which is exactly at the center with a rigid support. So because of this it will remain horizontal, that is in equilibrium. Now let us say that we have two weights W1 and W2. Those are, let us assume that they are unequal weights. Let us say that W1 is attached at the point A and W2 is attached at a point B. Now what will happen? The distances are unequal, the weights are unequal, so because of this the rod will perform either anti-clockwise or clockwise moments. Why? Because of the weight W1 at the point A around the point O, it will produce anti-clockwise moment, and the weight W2 around the point O at the point B will produce a clockwise moment. Now you have to adjust the weight W1 and W2 in such a way that again the rod comes to an equilibrium. That means it becomes horizontal again. So now if you calculate the anti-clockwise moment produced by the weight W1 at the point A around the point O is equal to W2 multiplied by the distance OA, and the clockwise moment produced will be equal to W2 multiplied by OB. So this is how anti-clockwise moment becomes equal to the clockwise moment, and that is how we verify the principle of moments.